broken home. I gave you all the bricks that I own and know. I'm letting go, I'm breaking these walls down, breaking these walls down. If you wanna adventure, then fly to home. But if you wanna travel, then go alone. Yeah, what's the point in us if I never know? Yeah, if you're gonna leave, I'ma let you go. I'm tired of the pain. Go away. I'm tired with yesterday. Harder, harder. I fell where my demons dwell. My own little nightmare, I call it hell. Oh well, it's time to get back up. Climbing and climbing, I'm done with this ride, is what I tell myself, so I could feel something else. Yeah, I guess I had my bad days, but it doesn't mean I lost my style. Darling, where were you when my heart was on the ground? I thought time would prove that you would stick around. I guess time stood still, a king without his crown. Now I'm breaking, you're faking, girl. You never made a sound. I'm tired of the pain. Go away. I'm tired with
Assalamualaikum and hello to everyone. My name is Farid Ahmad Pedestri, Matrix ID 2019250508 from class D. So I'm going to talk about the discussion. So, the value obtained is different from the reference value. This is because there will be error when conducting the experiment. Manual calculation can lead to slight error if not cautious. In other case, equipment can also lead to an error in the data analysis when not adjusted properly. Surrounding will also affect the result obtained, and some material will act differently in different temperature. So the mechanical properties of the sample is that steel have high in strength, ductile, hard and not brittle, while brass have medium strength, ductile and hard. Aluminium is low in strength, ductile and also soft. Yield point is a point on the stress strain curve, after which there is a significant increase in strain with little or no increase in stress. This point indicates the limit of elastic behavior and the beginning of plastic behavior. Meanwhile, the yield strength is the term used to the corresponding stress. The yield strength is defined as the stress at which a predetermined amount of permanent deformation occurs. Proportional limit is the point on the stress strain curve where the linear elastic deformation region changes into a non-linear plastic deformation region. Elastic limit is the maximum stress per unit area with a solid material that can arise from permanent deformation occur. Elastic limit is more important than proportional limit because elastic limit shows more information about the material properties. For example, elastic limit can decide either the material will be a brittle or not brittle. Stress strain diagram will give information about mechanical properties, while load deformation diagram shows information about deformation.
From the results that I obtained in table 4, steel is the hardest material than brass and aluminium. Steel have the highest ductility, that is 1.69 exponent 10. The reference value is different from the experimental value. The reason why is because while conducting the experiment, there must be an error or misread the value. Calculation was made by manual, so there must be a different decimal number or an error while inserting the value to the report. In other case, machine can also lead to error in the data analysis when not adjusted properly. Surrounding will also affect the results obtained, as some material will act differently in different temperature. Steel, aluminium and brass have some similarities in terms of mechanical properties and its brittleness. These materials are easy to break when subjected to impact. For ductility, these materials are also ductile. For the differences, steel have strong strength and strength for aluminium is really low. For the hardness, steel is harder, brass is hard, and aluminium is the softest. The yield point is the point on a stress-strain curve that indicates the limit of elastic behavior and the beginning plastic behavior. The material property defined as the stress at which a material begins to deform plastically is the yield strength or yield stress, while the yield point is the point at which deformation begins. The yield strength is defined as the stress at which a predetermined amount of permanent deformation occurs. The proportional limit is the point on the stress-strain curve where the stress in a material is no longer linearly proportional to strain. Elastic limit is force per unit area within a solid material that can arise before the onset of permanent deformation. Elastic limit is more important because it shows the limit before the material deformation and can decide the brittleness of the material. There are many advantages that we can get based on the stress-strain diagram. A stress-strain diagram gives us many mechanical properties such as strength, toughness, elasticity, yield point, strain energy, resilience, and elongation during the load. These diagrams show properties of a material such as Young's modulus, yield strength, and the ultimate tensile strength. The diagram can also be used to read off the elastic deformation limit, the plastic deformation limit, the maximum tensile strength, and the fracture or rupture point.
On table 4, steel has the highest for proportional limit stress and nominal fracture stress. Meanwhile, aluminium has the least. This is enough to prove that steel is the hardest between these three materials. The result and the reference value are different because there is such minor error while they conduct experiment in progress. Human error can occur if the person doing the experiment without any concentration. Lastly, the value will differ because of surrounding factor. The similarities in mechanical or material properties is ductility and brittleness. For ductility, steel, brass and aluminium is ductile. Moreover, for brittleness, these three materials is easy to break in such impact. The yield point is the point on a stress-strain curve that indicates the limit of elastic behavior and the beginning of plastic behavior. Yield strength is a constant that represents the maximum limit of elastic behavior. Proportional limit is the value of engineering stress at the point in the stress-strain diagram where the linear elastic deformation region transitions into plastic deformation region. Elastic limit is the value of stress that can be applied to the material without causing any deformation. Elastic limit is more important because elastic limit can show if the material will brittle or not. A stress-strain diagram gives us many mechanical properties such as strength, toughness, elasticity, yield point during load, while load deformation diagram shows the condition material under the impact but not directly.
conclusion, based on the experiment done, each material has different value of tensile loading. The investigation of general understanding about how different material and cross-section behave under an axial tensile loading was achieved. Steel, brass and aluminium all have different level of strength, ductility and other mechanical properties. Stress-strain diagram give a lot of information that helps in finding the material mechanical properties such as brittleness. The study of relationship of stress, strain and mechanical compression was achieved. The mechanical properties were obtained.
For the conclusion, we receive a lot of the information from the result for the mechanical properties such as the modulus of elasticity, the yield stress, the ultimate stress, the fracture stress and ductility ratio. After the experiment, we can know each material have different type of material properties. We found the stress-strain relationship and understand the purpose of it. We also can compare the mechanical and material properties of various materials and cross-section by conducting this experiment. General understanding of how different material and cross-section behave under an axial tensile loading was obtained successfully.
For the conclusion, the conclusion is of this experiment is we can know the general understanding of material behavior under the unaxial tensile loading. We also notice that the mechanical properties of the material and discover the stress-strain relationship as well as the differentiate of the mechanical or material properties.
If you're gonna leave, I'ma let you go.